Hello everyone, so this is part 2 and we're looking at energy profiles. Now here we have a picture of an energy profile. You might get one that is exothermic or one that's endothermic. Here we have one where the reactants, so actually let's label it first. So look at this diagram. The first thing you should do when you see this is to label it up, and it's good to practice this each time because you know where everything is. So at the very beginning of a reaction, we always have our reactants. So this first level is always our reactants. And then at the end of the reaction, we have our products. This bar here is the amount of energy. And quite often we call the x-axis the progress of a reaction. And you can see here, we've got an arrow. Now this arrow is how much energy is required for a reaction to take place. This is known as our activation energy. Now, there's usually an additional line that I'll just show you for now, just so you know. So where the products and reactants are from this point here, this line from products to reactants, this line shows us the overall energy change. Now, quite often in the chemistry, you will have to draw this either from scratch, or you'll be given the reactants and you got to draw the rest of it and draw the activation energy in, or you have the products and you got to do it backwards. Either way, these questions do exist. So just if you can label it each time, there shouldn't be no issue of you drawing this diagram. So as I said before, we've got our reactants here and our products at the end has less energy. This will assume that the energy has been released. And given off, this is an exothermic reaction. If the products are higher at the end and it's up here, this will tell you that it's endothermic, meaning that the energy has been taken in from its surroundings. So therefore the temperature is inside the products. So it's cooler on the outside to touch, but the product has kept the energy within itself. Right. So we've got our next question here. I'm just going to zoom out a tiny little bit, just so we can see the labels and the questions. So you're going to have to label diagram. So I've already done this, which makes it a bit easier. So we know A is the progress of a reaction. B, already labeled, is our activation energy. And then C is our products. All right, for our next question, and we're on to question 2 now. So I'm going to move the camera slightly. So question 2, we're looking at chemical reactions can produce electricity. We're looking at fuel cells ultimately, but this is also electrolysis. So if it was electrolysis, electrodes are usually made of graphite, because graphite conducts electricity because it has delocalized electrons. When this is electrolysis as well, because we have an electrolyte. An electrolyte is an ionic solution, meaning that we have ions that are free to move. So that means we have ions that are free to move and pass a charge. Now, even though this is electrolysis, we've got our electrodes, the voltmeter will be a signal for me, even though I would assume automatic is electrolysis. and we have our electrodes, and that would tell us that. However, because our voltmeter is there, this will tell me that it's actually about fuel cells and batteries. So it's actually a battery, a model of a battery. And the indicator would be that it's got a voltmeter there. If it was about electrolysis, though, so, and I wanted to make a point of this, if it's about electrolysis, we'll see a similar diagram, actually pretty much the same diagram, I'll be honest, of our electrodes like this. We'll have a battery. We'll also have a beaker. That's not a very good beaker, to be honest. A beaker with our electrolytes. And they'll be labeled in a similar way. So as you can see, these are very similar diagrams, but they show very similar things. So electrolysis, we will have a battery, and that will be us splitting, and you will have the label electrolyte as well, electrodes, and it'll be the splitting of the electrolyte, because electrolysis is the splitting of the solution. In this case, we've got a voltmeter. We're looking at a battery itself. Right. And then look at the next question. I think we'll find we're being asked about a battery. So which of these combinations would not give a zero reading on a voltmeter in the diagram above? Now, about to answer this question, that is, and then fuel cells and batteries are in the higher tier of the chemistry, combined and triple. So you're looking for a zero, would not give a zero reading. So that means it will show a reading. And the other three will not show a reading. So for a battery to show a reading, we need a pair. So to show a reading, we need a couple of things. A pair of use different metals. You look at a battery, an AA battery, anything, you can see that one side is like copper color, and on the side is a more silvery color. That means one side's copper and one side's zinc. We then inside have a alkaline solution or a salt solution that allow the charge to pass through, or for the chemical reactions to take place. So we first need a pair of different metals. We also need a salt solution for it to work. So from this, we can deduct which one is going to give us a reading. So copper and copper are not two different metals. Has got salt solution, so that's a yes, but this is a no. So it can't be this one. Water is not a salt solution, so no. Pair of zincs, no, not different, they're the same. Therefore cannot be this one either. Copper and zinc, two different metals. I also got copper and zinc here. It's correct. Water is not a salt solution, but copper chloride is a salt solution. There has to be this one here to give us a reading on the voltmeter. Our next question. Alkaline batteries are non-rechargeable. Why do alkaline batteries eventually stop working? Well, like anything in chemistry is alkaline. Alkaline's a chemical. Inside batteries, we have a solution inside it. This is non-rechargeable. Right, chemical, right. A chemical, therefore a chemical reaction is taking place. So there's a chemical inside. We assume when the charge is passing through, a chemical reaction is taking place. They're non-rechargeable. Why do alkaline batteries eventually stop working? Well, because it's an alkaline battery with chemical reactions. With all chemical reactions, when all the reactors are used up in the battery, it's not going to work. There's nothing else to react with. So that means all the reactants in the battery are used up. Why can alkaline batteries not be recharged? Now, the only reason why it can't be recharged is because it is not because as it's getting used up, it's getting used up. You can't reverse this reaction, therefore it cannot be recharged. So it is not a reversible reaction. Our next question, hydrogen fuel cells are rechargeable. Rechargeable lithium ions can be used to power electric cars. Complete then balance the equation for the overall reaction of a fuel cell. So with a fuel cell, we're reacting hydrogen and oxygen in the air to make water. So oxygen in the air is just going to be in pairs. It's because it's diatomic. So diatomic means it's in pairs. So you've got H, and so is hydrogen. It's H2. So that means oxygen is O2. We've got to balance our equation. I've got 2 hydrogens on this side of the equation and 2 oxygen on this side. 2 hydrogens on this side of the equation and 1 oxygen. So I need 2 more oxygens on this side to balance it out. So if I put 2 in front of here, I now have 2 oxygens, which now balances this side. So the oxygens are balanced. I now have 4 hydrogens, because it's 2 times 2, which is 4 hydrogens. Got 2 here. If I want 4 hydrogens in total, I'll then put 2 in front here. And now the equation is balanced. But next question is a question about comparing hydrogen fuel cells and a rechargeable lithium-ion battery. Now, I've got a table of information here that tells you information about the hydrogen fuel cell and the rechargeable lithium-ion battery. And quite easy to read. The question itself, I'm going to turn to one of my here. But the question that goes with it is evaluate the use of hydrogen fuel cells compared with rechargeable lithium-ion batteries to power electric cars. Use a table and your own knowledge to evaluate. So with our information, the best we can do is then add information about what we know about hydrogen fuel cells, which I'll go and write here in note form for you. So hydrogen fuel cells, mostly. So we've got information that time taken is shorter for a hydrogen fuel cell. Distance traveled is more in the hydrogen fuel cell. Distance is less though per unit in kilometers. The cost is more expensive for refueling and recharging, and the cost of the car is a lot more expensive. So additional knowledge we could probably add to support maybe which one is better. So hydrogen fuel cells. So hydrogen, so H2, is renewable if made with electrolysis. Lithium ions. Oh, okay, just 5 minutes, okay? Right, lithium ions. Batteries can catch fire. And catch fire. Of hydrogen fuel cells, water is produced, so H2O is produced. So there's no pollutants. No pollutants. Lithium ion batteries may release toxic chemicals. and lithium-ion batteries have a finite life. So lithium batteries have a finite lifespan, meaning that eventually they will run out. So these are arguments for a hydrogen fuel cell. So this here are 4 points for hydrogen fuel cells. If we want to argue for the lithium-ion battery, then we would say the following. So regardless of hydrogen being abundant, and I'm going to write just further down here, I'm going to write to the left actually. So hydrogen is actually often made from fossil fuels. So it's not renewable. Charging points. So charging points for electric cars. So charging points for electric cars are more available and accessible. Hydrogen takes up a lot of space. And it's difficult to store. Hydrogen is also very flammable. It's very flammable and explosive. And then even with electric cars, no emissions produced. So these are points that are 4. So these are 4 lithium ion batteries. Now, because the question is an evaluate question, which I'll put here. So it says evaluate, you'll have to compare. So you have to make a comparison between the two. Then you have to give a judgment. And when I say judgment, it's what you feel strongly about, then you have to give evidence to support your answer. 1 second.